All right, so if you'll go ahead and start the warm-up, this will be what we did yesterday. So if you want to pause it, I'm going to go ahead and jump right into it, but if you want to pause it, then you can try to do it on your own. All right, so for A, so remember that we treat these things kind of separately here. We say, first, if we look at the top, 3x minus 5 all by itself is just a linear function. And linear functions do not restrict our domain in any way. So no restriction there. So far I don't have any work to do. It would be negative infinity to positive infinity. But, of course, I'm not done. Now I got to look at the bottom. And I say, well, the bottom is a square root. So because it's a square root, I'm going to set it to be greater than or equal to 0. Not only is it a square root, though, but it's also in the denominator. And so now I say, also, denominator cannot equal 0. So if you put these two things together, then really what's going to happen is I'm going to say, well, the radicand, x, not only is it greater than or equal to, but also not equal to. So that inequality is going to change just to greater than. Okay, and so this is our only restriction. X is greater than 0. So on a number line, how you show greater than 0, if you like the number line method, it's a good method. Here's 0. And on the 0, I'm going to have an open circle because I cannot equal it, and I'm going to go to the right because it's greater than. So that represents, so where do you start? So I'm over here, I start at 0. Remember, we're not going to touch 0, and I'm going to go forever that direction. So that's 0 to infinity. And that's it for question A. All right, B. So this is question B. Square root on top, 2x plus 1 over x minus 7. So if I start on the top, I say, well, the top is a square root. Square roots have the rule that they have to be greater than or equal to 0. And that's the rule for that. So I'm going to go ahead and do that. 2x plus 1, that's the radicand, must be greater than or equal to 0. So if you subtract 1 and divide by 2, so far, this is our restriction. If you want to go ahead and start your number line, you can. I'm going to wait till I do the other part. So the other part is x minus 7. Now, x minus 7 all by itself does not have a restriction. But not only is this x minus 7, but it's an x minus 7 that's in the denominator. And because it's in the denominator, it cannot equal 0. So therefore, x minus 7 cannot equal 0. Add 7, x cannot equal 7. So I have these two restrictions. So multiple restrictions, the number line is extremely helpful here. I like to include 0 just as a middle point. All right, so here's negative half. And here's 7. So negative half gets a closed circle because it's okay to equal. And I'm going to go greater than. That's this way. And at 7, that was this one, I need to do an open circle. So when you have more than one restriction, you want to say, well, what's the lowest it can be? So if you come over here to the lowest, your lines don't exist over here. We don't get to start until, say, right here at negative half. So if I highlight this in, let's do purple. So if I start at negative half, keep in mind we do get to start there. I go on, I go on, I go on. At 7, I'm going to have to skip that, and then I go on again forever. So this is just kind of a visual representation, again, of your interval. So negative half, I got to touch, so that's a bracket. I go on until I get to 7, And then kind of look at what, when you skip, it looks like a U. You want to skip over 7. Remember, we're not touching 7, so that's why those are parentheses. And you don't touch infinity, so that's another parenthesis. And that's it for question B. All right, question C. Now, before I do question C, I want you to look at the similarity between B and C. They both have a square root. They both have this x, this one's plus 4, but this one's minus. It doesn't matter, but the steps are going to be very, very similar, even though the answer is going to come up completely different. So if you want to pause it again and try it now after you've tried B, you can go ahead and do that. I'll go ahead and start though. So this is a square root. I'll go a little bit faster on this one. And we say square roots are greater than or equal to 0. So 3x minus 1 is greater than or equal to 0. Add 1 and divide by 3. So far I've got one restriction. X is greater than or equal to a third. Now here, x plus 4 would not give me a restriction except for the fact that it's in the denominator. So it can't equal 0. So x plus 4 cannot equal 0. So x cannot equal negative 4. So I make my number line. So here's a third. And over here's negative 4. So I'm going to get an open circle at negative 4. Let me do that in red. Open circle at negative 4 for this. And at 1/3, I get a closed circle, but then I want to be greater than that, so I'm going to go this way. So if we look at where I would start, this open circle is showing me don't be negative 4. But I already knew that I couldn't be negative 4 because I had to be greater than a third. That's what this part is saying. So if I try to do this highlighting thing again, over here when it's negative infinity, I'm nothing over here. This is just saying don't be negative 4, but I wasn't negative 4 anyways. So I'm not going to start until I hit a third. So I'm going to hit a third and say, okay, that's okay. And then I go on forever. So a third to infinity. And that's it. All right, so let's go ahead and do our domain, or do our notes today, which is piecewise functions. So a piecewise function, if you want to define a piecewise function, it's just putting multiple functions or pieces of multiple functions together. So putting pieces of multiple functions together. There's lots of ways you can do this. I found that the easiest and probably most clear way is to apply a table to our pieces. So I'm going to do that method. If you think you can do it a little bit faster, you can do that. But this is a really clear representation. So let me explain a little bit more about what piecewise functions are. So I'll do this one. So I read this. F of x equals x squared for all the x's greater than or equal to 1. So that means for 1 and x is greater than 1, 2, 3, 4, etc., I'm going to use x squared. Then I have my second function. For f of x equal negative x plus 1, use for x's that are less than 1. So don't include 1 and then the numbers less than 1. So that's like 0, negative 1, 2, 3, etc. Okay? So I'm going to put a table, and I'll do this color coordinated XY table for the black one, and an XY table for the blue one. So for this table, I'm using f of x equals x squared for x is greater than or equal to 1. Now, I think it's easier if you just always start with this critical number it tells you to start with, which is 1 in this case. So I'm going to start my table at 1. And then the numbers that I'm going to put after that are according to the inequality that x's have to be greater than or equal to 1. So x's that are greater than or equal to 1 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we'll stop at 5. Okay, and if we want to go ahead and figure out what the y values would be, so I'm going to do 1 squared. So that's 1. Here I'm going to do 2 squared. So that's 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So this is my table for my first function. Now let's do the other table. So for my other table, now I'm using negative x plus 1 for all the x's less than 1. I still recommend that you start with this 1 value. And then you want to do all the x's that are less than 1. So that's going to be less than, so 0 going down. Negative 1, negative 2, negative 3. So I do about 4. That's, or 5 total, 4 more. All right. If you have a question right now, you should have a question. Think about why you should have a question right now. So we were doing this chart, this table, for all the x's less than 1. So what I'm trying to accent right now is the fact that this was supposed to be less than 1, not equal to 1. So when you see a graph and you think about getting really, really close to 1 but not actually touching it, what would that look like on a graph? So that's going to have an open circle on this point because you're not actually supposed to touch that 1, but you're going to get super, super close. And that's again because the lack of or equal to right there. Okay, so when I plot this point, I'm going to use an open circle. Everywhere else will be closed. That 1 will be an open circle. So let's go ahead and figure out those corresponding y values. So plugging in a 1 here, so negative 1 plus 1 is 0. Plugging in a 0, negative 0 plus 1 is 1. Plugging in a negative 1, negative 1 is positive 1, plus 1 is 2. So if you need to do some more math here, I can show you this step if you want. So when I plug in a negative 2, I have negative 2 plus 1, and that's 3. So you can also kind of just see the pattern going on, 0, 1, 2, 3. If you plugged in negative 3, negative 3 plus 1 is 4. So if you don't get 4, I mean, the pattern just kind of leads you to that conclusion also. All right, so let's continue here. All right, so I've got both of these tables, and I need to do my graph now. So I'll do, again, still in colors, I'll graph this one in black, and then I'll graph this one in blue. So let's just do the black one for now. So I have the point 1, 1. So I'm going to try to make this as big as I can without losing my table. So 1, 1 is here. Remember, I'm going to do a dot everywhere except that one place is going to be an open circle. 2, 4. 3, 9, and then 4, 16 runs off the page, so I'll have to stop here. And then we connect those 3, and remember that you go forever in that x direction, just in that one x direction. So this is the f of x equal to x squared, and that was only for the x's greater than or equal to 1, which is why we started at that 1 and then went greater than, so only went numbers more than that, okay? All right, now in blue, I'll do my other function. So at 1, 0, make sure you put an open circle and make it really obvious to me that that's an open circle. I have to grade this, so make it really obvious. All right, 0, 1. Now everywhere else is a closed circle though. It's just that one place. Negative 1, 2. Negative 2, 3. Negative 3, 4. Well, now I can connect all of that. Okay, and so that's my function, negative x plus 1. And that's it. That's my graph. If you think about piecewise functions, this is two functions pieced together to make one. So for all the x's less than 1, I use this blue line. So I'm moving along my function. I'm moving to the right. I continue to move to the right. Eventually, you're going to come to 1, and you're going to say, well, I have to jump off the blue. And right as 1 starts, I'm going to jump on the black. And I actually start on that black dot, and then I go on forever to the right. So left to right exists everywhere, so that's negative infinity to infinity. Now, your bottom to top does not. Your bottom does not exist, and you don't start to exist until you get to right here. Right there you exist, but not really, right? That's at 0, but we don't actually get to touch that 0. But then I'll go forever up. And that's it. All right, so let's go to page 2. So I am going to have to skip example B. We skipped it in class. If you notice, they forgot to give you that second equation, so we can't even do that anyways. So let's go to example C. So if you want to try to do example C on your own, that would be good. And I'll go ahead and kind of move faster, but not super fast. So x, y, and we're going to start at the 2, and we want to do numbers that are less than 2. So 1, 0, negative 1, negative 2, negative 3, that's probably good. And, you know, you got to go to negative 9, so as long as you can kind of start to see the pattern. All right, we can go ahead and do the x, y table for this one. X, y. Remember to start at 2, but then we want to go x is greater than that. So 3, 4, 5, 6. And then also make yourself a quick reminder, this guy, due to the lack of or equal to, will be an open circle. Everywhere else will be closed. All right, so if you want to pause at this point and get the corresponding y values, you can. I'm going to go pretty quickly. 2 plus 1 squared is 3. 3 squared is 9. Minus 2 is 7. 1 plus 1 is 2. Squared is 4. Minus 2 is 2. 1 squared is 1. Minus 2 is negative 1. 0, negative 2. Negative 2 plus 1 is negative 1. Squared is positive 1. Negative 1. 4 is 2. Okay. So if you want to go ahead and graph this, you can. It doesn't really matter. 2 comma 7. 1 comma 2. You don't have to do it in the same order as me. You could be getting the blues right now if you wanted to. This is good. I can definitely see that U shape that's happening because it's a quadratic. And it goes forever in that left direction because it's less than or equal to. And it's that or equal to that makes that a very closed circle right there. Okay. All right, now if we do the blue. So again, if you want to pause to do the algebra, you can. We do 2 minus 2 is 0. 0 squared is 0. Negative, right here, that's that negative symbol. Negative 0 is still 0. Plus 5 is 5. All right, now let's do the 3. So 3 minus 2 is 1. 1 squared is 1. Negative 1 is negative 1. Add 5 is 4. Plugging in 4. 4 minus 2 is 2. 2 squared is 4. Negative 4. Plus 5 is 1. Plugging in 5. So here, let me write this one out. So I have 5 that's getting plugged in right there. So I have the negative symbol. 5 minus 2 squared plus 5. So that makes 3. 3 squared is 9. So negative 9, because of that negative symbol, plus 5 is negative 4. Okay, so if you want to write out these steps for every single one, you can. That's perfectly fine. get a scratch piece of paper, whatever you need to do. 6 minus 2 is 4. 4 squared is 16. Negative 16 plus 5 is 11. Negative 11. All right. 2, 5. Put an open circle there. 3, 4. 4, 1. 5, negative 4. And we go down. Okay. All right. Domain still exists everywhere. And range this time, bottom to top, also exists everywhere. And that's it for today.